2013 short questions. We're going to solve A3, which is a short question requiring you to use a section plane. Complete the plan showing all lines of interpenetration. Use a section plane to find the crossover points on edge DE. So there we have DE in our plan, which is contained as a point view here in our elevation. Before we move on to that, we'll solve the first part of the question, which is getting all other intersection points. We can see there we have this surface here in blue contained as an edge view in our elevation. That means we're going to be able to get these three intersection points here in our plan. This one here will come down, and where that comes in contact with the top of our triangular prism, that's going to give us one intersection point, and if we bring down this point here, it's going to give me two more, and then we'll put in the hidden detail. We can do that as well on our left hand side. As we have the edge view here, we can bring down this line here, and that's going to give us our two intersection points here. And as we have the edge view here of our top surface, that's going to give us another intersection point down here. To get the crossover points, we use a section plane. We can use an infinite number of section planes here that go through edge DE. And just to prove that, we're going to solve this question 5 different ways. First way is getting our section plane through the top surface, which is going to be a horizontal section plane. That's going to give us our two intersection points. The second way is getting a section plane parallel to the base of our triangular base prism, and that's also containing the edge DE. The third way then is going to be an inclined section plane containing our back 2 points of our prism. Our fourth way then is an inclined section plane containing the front 2 points of our prism. And finally, the fifth way we'll solve it is getting an inclined section plane on a surface, which is this one here. We'll look at them in a bit more detail now. To get our horizontal cutting plane, we'll take our cut across here in our elevation, bring that down then to our plan, and we join that back to this intersection point here, and that's going to give us our two crossover points. And there we have the question completed using a horizontal cutting plane. We'll solve it here using an inclined section plane on a surface. So here we're going to take a cut here containing this surface, bring that down to plan, and draw in our inclined section plane here in plan. That's going to give us our two intersection points, which we can see here in purple. And that completes the question for us. We'll have a look here at random inclined section planes. So we'll take a cut across here, draw that then in our plan, and that's also going to give us our two intersection points. We'll take a cut here above in our elevation, which is a random cut containing the edge DE. Draw that again in our plan. That's also given us our intersection points. And one final inclined cutting plane, which contains our bottom point here, and it's going through edge DE again. It has to. And that also gives us our intersection points. So we can take any section plane here as long as it goes through DE, and that should give you your crossover points.